Afternoon, students. The next topic of Module 1 in MLOps is Implementation Roadmap of Machine Learning Operation. We discussed how machine learning algorithms we are identifying, how a team is framed within an organization. So the next step is how we are implementing or deploying this developed machine learning model to the outsource or to the end user. Okay, so this implementation roadmap is having three phases. First one is infrastructure setup with machine learning model development, and in the phase two, which is called as transition to operation, and the phase three is machine learning operations. Okay, so the roadmap is having totally three steps. So it ensures that the successful implementation of machine learning model to the end user. That was the main goal. Not only developing or creating an model is important. Successful implementation, deployment, monitoring is very much important in the MLOps concept. Okay, so this is having three phases. So we'll see about one by one phases. The next slide. So the phase one is called as machine learning development. So this is the basic steps what we learned in the previous classes, like we are defining the problem with some input data set. Then that input data set is divided into training and test data set. After that, we are using proper machine learning algorithm to find the solution or output for the proper model. Okay, so that is done in the phase one. So the important thing in phase one in machine learning development is the infrastructure setup. Okay, so we have to define which tools we are using. What about the infrastructure? How we are training the model? How we are packaging the model? Everything we are deciding and developing a model or creating a model within the first phase of the ML development. Okay, so in this first step, what the outcome or output we are receiving is a robust and validated machine learning model which is ready for deployment. Okay, so the coding is ready, the environment setup is ready, the tools are ready, everything is ready in the first step. Okay, which means sometimes software or a model may need different infrastructure. It may run in it may need a server side background tools, whatever needed, or it may need a set of library files, whatever files, models, or data infrastructure setup, different tools it needed. Everything is decided, finalized, and proper model is created and serialized within the machine learning development phase one. Okay, and in the second phase is called as transition to operation. Okay, so we developed a model in the phase one. So the next step is model serialization, deployment, and quality assurance. Okay, so we are preparing a model for deployment. So we know for deployment we need any container. Okay, either we need a DevOps or GitHub. The containerization concept we are applying here to set up the proper environment for the model. Okay, because different types of model may need a different kinds of background environment. Okay, the server specification, the proper PyTorch tools or coding, we may use a Python or it may use a web page, whatever it is. Okay, everything is packed and ready for the deployment within this model serialization. Okay, so for deployment, we have to use the CI/CD pipeline here, and the quality of the model is very, very important here. So after deployment, the quality is tested and the performance is analyzed here using various different performance metrics such as F1 score, bias, etc. Okay, so in this second phase, the model is deployed to the production environment. Okay, so the second step or second roadmap of the MLOps is over. Then the third one is operation. So finally, we deployed the model to the end user. After that, we are continuously monitoring and learning. And if there is any error is generated, we are creating a solution for that error. Okay. So a performance of the particular model is tracked based upon various metrics, and we are checking whether it's creating any issues. Then in this third step, based upon the present environment, the model input is trained in based upon the latest input. Okay, continuous training or continuous updation of the model input is very much important in the machine learning. So model training, continuous learning, and error resolution is done in this third phase. Okay, so the outcome we are getting from the third phase is efficient, scalable, and reliable machine learning operation. Okay, so these are the three things we are doing in the machine learning roadmap. Okay, so we are setting up the environment is the first step, infrastructure setup, and we are training a model, taking a proper data set. From that data set, we are training and testing a model with various kinds of data. And finally, the code was developed, the input and output was tested, and the model is ready for packaging in the first phase. Then in the second phase, the model is deployed with its necessary tools, libraries, and infrastructure needed, whatever it is necessary. Everything is deployed by using any one of the containerization concept, either using Docker or GitHub. So in that case, we need a CI/CD pipeline to deploy a model. Okay, in this deployment, we are deciding or checking the performance of the model also with different kinds of metrics. Then in the third phase is operation. So after deploying the model, the performance is continuously tracked and the issues are rectified if any bias or errors are getting in from the model. Okay, the solution is addressed, the issues are addressed in this. So the outcome of the model will be scalable, reliable machine learning model with good operations and outcome we are receiving. Okay, we need to have a good quality of data. Okay, so the main concept or main thing of the creating machine learning model is the input data. Okay, we must need an input data set. So that input data set must be in a quality data. Okay, we have a quantity of data. So the quantity may have n number of attributes. From the n number of quantity data, we are reducing the size or cleaning the data with the higher quality of data. If the quality of input data is good, then only we can able to achieve a proper performance level or a proper outcome of the machine learning model. Okay, so the two important factors in this procuring data is data quantity and the data quality. Okay, so the data quantity means sufficient data samples to train an effective model. Okay, we need, if we are training a model with 100 input image or 200 input image, their performance may not be in the, up to the mark. Okay, so we need to train a model with high quantity of data, and the quality of data could be very good and clear, which means in the quality, we are checking the consistency, correctness, and completeness of the data. Okay, whether the input data is correct. If, for example, if you are identifying whether the particular picture is or whether the animal moving in the forest is dog or cat, means we have to train a model with the proper cat and dog image. Okay, we can't able to train the model with the horse image or elephant image, because our outcome is whether the particular animal is a dog or cat. So we are training the model with the cat and dog images only. Okay, so this is called as the correctness of the data, correctness, consistency, and completeness of the data. Okay, so these are the two factors we have to concentrate at the time of procuring the data, quantity and quality of the data. Okay, so in requirement analysis. So in requirement analysis, first one is role of product owner. Okay, he has to define the type of data, what type of data they are giving, and what would be the performance requirement. Okay, For example, in a road, we have a CCTV camera. Okay. So, in the CCTV camera itself, it can easily identify whether a bus is moving, whether a two-wheeler is moving, whether it is a car, whatever it is. How it is identifying? Already, a model is trained with the car image, bus image, two-wheeler, etc. Okay. So, same thing, whenever a model is created, the first step is the product owner should have the idea, and he has to give the proper definition or a proper explanation for the input data and the performance metrics. What outcome he needs from the input data. Okay, that is the first requirement analysis. Then second one is data requirement. So the data requirement, maybe we have to specify the quantity, quality, and ethical consideration. Quantity and quality we learned in the previous slide. Okay, quantity of data and quality of data. Okay, so the second requirement analysis is data requirement, and third one is clear requirement guide the development of robust ML system. Okay, so here it is splitted as elicitation, analysis, specification, verification, and validation. Okay, so elicitation means we are checking whether any additional data needed. Okay, so we are collaborating or communicating with the stakeholders, data scientists, and legal experts to get the proper characteristics or protected characteristics of the model. Okay, then the performance of the particular model is analyzed, and if there is any outlier or errors are getting in, that could be analyzed in the analysis level. Then specification means data requirement explainability. The legal and regulatory considerations are checked in the specification. The operational data and bias, retraining the machine learning model, detecting the data consistency, everything is done in the verification and validation. Okay, so at the time of developing a model, we need these three requirements. One is role of product owner is very, very important. Then data requirement. Then we are moving to the steps: elicitation, analysis, specification, and verification and validation. In the verification, or after producing the model, or after we are transferring the model to the end user, deploying the model to the end user, retraining of the input data set is very, very important. Okay, retraining a model with new data is important. That should be done proper in the deployment side or verification and validation side. Okay, then the tools and infrastructure. So there is a lot of tools available nowadays for doing this ML operations, such as Airflow, Databricks, TensorFlow, PyTorch, and Skitlan. We'll use PyTorch and TensorFlow in our lab, and we are mainly using or getting the support of cloud services, because we know we are processing the big data. Okay, we know the concept of big data. If the data is over 10 TB, we are calling that particular data as a big data. So we don't have the facility store that kind of data in our personal systems. Okay, so in that cases, we are approaching the services of cloud. Okay, cloud-based storage. So we may use the Microsoft Azure Cloud, AWS, and Google Cloud. Mainly this AWS and Microsoft Azure is asking a payment to get them access, but we can use the Google Cloud to store the data, as well as testing our models. We can use the Google Cloud. Okay, so at the time of developing and deploying the ML model, we have to check the tools, proper tools, and identifying whether the tool is supportive for our this defined model. Okay, that we have to ensure which algorithm we are applying, and based upon the size of the data license, we can go for any one of this storage service, cloud-based service. Okay, so in this first module, the real-time example they have chosen is cargo shipping company in Finland. So they are forecasting weather condition to optimize port operations. Okay, so the problem statement given there is develop an ML solution to predict weather conditions 4 hours in advance. Okay, so you please think only 4 hours in advance the model is generating or predicting a weather condition. So every time the model would be trained with the new data, input data. Okay, retraining, a model retraining is very much needed in this machine learning. Okay, so this is the problem statement. For this problem statement, a model is developed. Or you can also take the data set of this cargo shipping company and try to find the predict the weather condition of the particular port. And for implementing this problem, to create getting a solution for this problem, they use the tools Microsoft Azure Cloud Service and model management for ML flow. And they created a setup for Azure subscription and machine learning space. Okay, so from this, by applying proper tools and necessary data, they can able to judge or get the weather condition in prior. They can able to predict the weather condition in prior 4 hours. Okay. Then data pre-processing also one of the step. These things you need already know when you are doing any one data science lab or machine learning lab. The first step is data cleaning. So where there you are removing inconsistencies, null data, null values, everything you are removing, and only the necessary data we are keeping as rows and columns. Okay, that is called as data cleaning. Then data transformation means converting the data into suitable format. Okay, sometimes the data sets may be in the different format while you are importing a input data or an input file, CSV file to a model. The data set may be in a common format. Okay, same format. So we are converting a data into suitable format, which means we need a CSV file. Okay, to giving us an input. So that is called as data transformation, and in feature engineering, extracting relevant features for model training. Okay, a data set CSV file may have a number of rows and columns. Okay, it doesn't need that much of attributes to train a model. Okay, only necessary attributes we can extract from the given input data set. Okay, that is called as feature engineering. Only necessary features we are getting to train our model. Okay, so the model training is done with the training environment. So the training process is done with the pre-processed data, and the particular model is evaluated with the various performance matrices. Okay, so in the performance metrics, we can divide it into two types. The performance metrics which is used for classification model is accuracy, precision, and recall. Metrics used in the regression model is RMSE and MAE, which means mean square error. So in the validation technique, we are using cross validation and holdout validation. Okay, so students, please keep these things in your minds. If you are using classification algorithm, you will get the accuracy, precision, and recall as output. Then in regressions model, you are getting RMSE and MAE. Okay, so in deployment, you need a CI/CD pipeline and production environment to get the API endpoint and batch processing. Finally, a model is performance is monitored using the metrics, and errors are detected, and the log is maintained for tracking the model behavior and issues. So from this, a continuous learning is carry out using the model. So in continuous learning, we are retraining the model, updating the model, again monitoring the retrained model. Okay, so retraining is done with the new sets of data. Okay, and in the production side, the model is updated and deployed with the support of production side, and it is monitored in the endless manner. Okay. Then same case study we can execute here. Then the benefits of MLOps is we can get the efficient result. We can avoid manual operations. We can go for machine machine related operations using this hybrid algorithms. Okay. So benefits is efficiency, collaboration, scalability. And the example we have is improved model deployment with speed better and resource management. Okay. And some challenges the MLOps is having is lack of transferability, high cost, and intangible systems, that which means continuous monitoring is important. Okay, that was one very big challenge. If we are not updating the model with the new data, updated data, it won't give the proper accuracy and proper result. Okay, so implementing robust process using appropriate tools and collaboration is a drawback or challenge in MLOps. Okay, then future MLOps, this is an emerging area. Okay, we need increased automation, improved model complexity, and enhanced security. Security is one of the major thing because we are processing the data and we are using cloud storage. Okay, so we must need a security there in the storage side, cloud services. Okay, technology also, we can use various newest algorithms and machine learning tools. So more efficient and scalable ML operations are the opportunities the future MLOps focusing on. Okay. And this is about the challenges, benefits, such as case studies, as well as business problem, mm, and the phases of machine learning deployment model. Okay, these are the implementation roadmap for a machine learning operation. Thank you.